Hello everyone. Today we are going to solve the problem which is closest number. So in this question there is a given two numbers which is n and m. M is not always equal to 0 and the problem is to find the number closest to n and which is divisible by m. So if there is more than one such number, then the output should be the one which is having the maximum absolute value. So if you see the first example, n is equals to 13 and m is equals to 14. So the values which are closest to the number n and also divisible by 4. So for 3 is 12 and 4 is 16. So 12, 16. From these two, the closest number to the 13 is 12. So the output is 12 like that. So if it is negative, then we need to return the maximum absolute value number. So it is obviously the minus 18 because for both minus 12 and minus 18 are closest to minus 15. But when we check the absolute value after ignoring the distance which is equal, then 18 will get the absolute value greater than 15. So what is the approach? We find first q, which is quotient of n by m. Next, number 1, which is result 1, possible one, will be q and quotient into divisor. And if both numbers are greater than 0, means n1 and n2 both greater than 0, then we will find the second number as n2 will be our quotient plus 1 into same divisor. So if n1 and n2 any one of them is negative, then obviously the second number is going to become q minus 1 because we need to achieve the maximum absolute value by going before multiples. So we check the of numbers from the original n. If both are at same distance, then return the maximum absolute value from n1 and n2. That's it. This is a small approach we are going to use. So how to implement it? So first we need to find the quotient, which is q is equals to n by m. That's it. So now n1, the possible closest number 1 will be quotient into divisor of n by m. And if we can say that if n into m, if it is greater than 0, this means both numbers are positive numbers. So the second number we declare here for total method axis, n2 will become q plus 1, means the second possible number into divisor. So if any one of them is negative, then n2 will become before multiple, which is q minus 1 into m. So we check the conditions as we wrote in the below section. So if we'll calculate the distance, d1 is equals to math.abs of n minus n1, d2 is equals to of n minus n2. So distance are calculated. If d1 greater than d2, then return simply if d1 is greater than d2, then that means the closest number is d2 distance, which is n2. So else if d1 is less than d2 distance, then return n1. That's it. So if both are equal, then return mat dot max of a base value of n1 comma absolute value of number 2, closest number. So that's it. Sample test case is passed. Hidden test cases are okay. We see it is failed. So okay. We need to return the actual numbers. So okay, make one thing. We check with a base value and return the original value. In this way, we check with the maximum absolute value but return the original value. So we can see the question is passed all the test cases. So coming to the time and space complexity, time will be, so we didn't use any loops, so it will be big of 1. So next, space will be, we use some normal integer variables 1, 2, 3, 4, 5, so not more than that. So the all take around 4, 4, 4, 4 and about 5, so 20 bytes. 4, 5 are 20, so 20 bytes. So 20 is also a constant, so constant space. So if you see the expected, big of 1, big of 1, so they are matching. So this is a acceptable solution for the given problem. This problem link is given in the description, so kindly go and practice the problem. Thank you for watching.